Okay, this video is to go over a sinusoidal function. So as definition said, a sinusoidal function is a function that is defined by the formula of the form f of x equals capital A times cosine of quantity of ax plus b plus capital B, or f of x equals capital A times sine of the quantity of ax plus b plus capital B, where capital A and B are real numbers. So what it says is that if you plug in some numbers in capital AB or A or B, the wave changes. So the cosine wave, let's take a look. The basic cosine wave is just simply starting from, not starting from, but it hits 0, 1. The wave hits 0, 1, and just normal wave. And the sine wave, on the other hand, is that it hits origin, and it has the same wave. So cosine and sine waves are pretty much the same shape, but it's slided to right or left. So what would happen if we plug in some number before sine? For example, 2. How would it look like? Okay, the wave actually gets bigger. Now, instead of hitting it hits the origin, but the highest point is no longer y equals 1. It's y equals 2. What if we plug in 3 or 4? The wave gets bigger. What if we put some number like half? Oh, the wave gets a little smaller or shorter. So that's what it does. That's what the constant, that's what the capital A does. This, if you plug in some number for capital A, then it goes up and down. Actually, the wave gets bigger or smaller. What if we put some number right in front of x? So now we have sine of 3x. Now we have, let me just change this into the view to something different. Let's make it trig. So now if you look at 2 pi, the basic sine wave, it takes 2 pi to have one big wave, as you see right here, right? But if you look at sine of 3x, that fits 3 waves fits in 2 pi. So in other words, the period that occurs is 1/3 of 2 pi. So the period equals 2 pi divided by number of waves, which is 3. Or we can put in general form, P equals 2 pi over A. So if you take that equation, P equals 2 pi over A, and if you solve for A, so I'm going to multiply A to both sides. The A divided by A makes 1, so 1, so the right side will be 2 pi. And then I'm going to divide P to both sides. And P divided by P makes 1. A times 1 is 1. So now we have 2 pi over P. So A equals 2 pi divided by the period, or P equals 2 pi over A. So that's what A does. So before we do the smaller case B, let's go over capital B at the end, or it could be in front. Let's put, for example, -1. So the basic sine wave goes down 1. I'm sorry, -2. What if you put positive 3. So now how would sine of x plus 3 look like? It's the same shape of sine of x, but it goes up 3. So that's what it does. That's what capital B does. How about if we plug in some number for smaller case b? For example, negative 3. How would that look like? So now we're going to look at the sine of x minus 3. So as you see, the wave actually shifted 3 spaces to the right. So if you remember from algebra 1, algebra 2, the transformation of the function, it applies here as well. So if you put positive 2, then the wave shifts 2 spaces to the left, or 2 units to the left. Okay, so that's what sine wave, that's what those parameter we call does. So if we have 2 sine of x, 2 times sine of 3 quantity of x minus 2, let's say 4, plus or negative 3, for example. How the wave look like compared to the sine of x? So right there says 2, so the wave should be bigger, right? The highest point should reach 2, compared to the normal wave. Now 3 waves should fit into pi, and 4 spaces will be shifted to the 4 units will be the function graph will be shifted 4 units to the right, and then this is what we call vertical displacement. So the wave goes down 4. So let's see how it looks. Oop, that's it. So the lowest point it goes is 4. What did I do right? Oh, negative 3. So vertical displacement is negative 3. So it goes down 3. And then it goes up 2 from there. So the highest point is negative 1. And then the lowest point, we can't really see it here. But lowest point will be 2. It goes down 2 from negative 3. So it should be negative 5.